All right, so let's move on to physical host security controls, and let's start by talking about the secure areas. Now, a secure area is primarily designed to store critical assets with a higher level of access protection than general office areas. But obviously, when I'm talking about critical assets, I'm not talking about the extremely critical assets that you might find in Area 51. I'm pretty sure you've heard of Area 51 before. It's this very mysterious and highly secured area in the United States where, some people might say they've got, alien spacecraft and things like that there. Who knows? Anyway, the most vulnerable point of the network infrastructure will be the communications or the server room. Now, this is why when it comes to creating the server room, installing equipment within secure cabinets will provide mitigation against insider attack and attacks that have been broken through the perimeter security mechanisms. So even if by some means you've had a social engineer who has gotten into the building before they can access the server, if the cabinets have, or if the servers have been secured in cabinets with locks and keys, it's going to make it very difficult for them to gain access to them. So some data centers may contain racks with equipment owned by different companies. This is called colocation. And these racks can be installed inside cages so that technicians can only physically access the racks housing their own servers and appliances. Now, here's an example of such. You can see right there, basically you've got the server inside of a cage. So this is extremely secure. Now we also have the concept of the air gap and DMZ. Now an air gapped host, this is one that is not physically connected to any network, and such a host would normally have very stringent physical access controls. Now an air gap within a secure area can serve the exact same function as a DMZ. And why? Well, because it is disconnected from any network, and then the physical space around the host makes it easier to simply detect unauthorized attempts to approach the asset. Now, we also have protected distribution and Faraday cages. A physically secure cable network is referred to as a protected cable distribution or as a protected distribution system, the PDS. Now, there are two main risks involving this kind of setup. An attacker could easily eavesdrop on the traffic by using a tap, or the attacker could simply just cut the cable, which would result in a denial of service attack. So a hardened PDS, this will be one where all the cabling is routed through sealed metal conduit, subject to periodic visual inspection, and then an alarm system could also be installed within the cable conduit so intrusion systems are detected automatically. Now, it is also possible to install communications equipment within a shielded enclosure known as a Faraday cage. And this cage is a charge conductive mesh that blocks signals from entering or leaving the area. Let's also talk about heating, ventilation, and air conditioning. Now, environmental controls obviously will mitigate the loss of availability through mechanical issues with equipment such as overheating. We don't want this. So I'm not sure you need to know this specific information for the exam, but it's still good to know. But generally, for computer rooms and data centers, the environment is typically kept at a temperature of about 20 to 22 degrees centigrade and a relative humidity of 50%. I don't know if you've ever entered a server room before, but they are usually very cold. I remember when I used to work as a systems analyst and I had to go to the server room, I would always have to carry my sweater with me because it was a very cold place. And then hot and cold aisles. A server room or a data center should be designed in such a way as to maximize airflow across the server or the racks. Now, there is a very important style of actually placing your servers in a server room. See, the servers, they are placed back to back, not front to back. And the reason is because we don't want the warm exhaust from one bank of servers forming the air intake for another bank. Now this is what we refer to as the hot-cold aisle arrangement. I have the diagram right here from 123rf.com. You can see right now that the front of the server will never face the back of another server. Never, ever, ever. It's always going to be the back of the server facing the back of another server. That's how it is supposed to be. All right. Fire detection and suppression. Fire suppression systems work on the basis of the fire triangle. Now, the fire triangle states that in order for there to be fire, we need heat, we need oxygen, and we also need fuel to ignite and burn. So basically, the idea of fire suppression is to remove any one of these three components. Now, we could use overhead sprinklers that can help, but there is the risk of the pipe busting and accidental triggering as well, and then the damage that it could cause in the event of an actual fire. Because guess what? Sprinklers contain water, and water they can cause electrical fires and things like that. There are several alternatives to sprinklers. We have the dry pipe. Used in areas where freezing is possible, water will only enter this part of the system if sprinklers elsewhere are triggered. We have the pre-action. Now, this system will only fill with water when an actual alarm is triggered. So there is no risk of the pipe bursting and then water all of a sudden spilling on the computers even when there was no alarm. And then we can also use halon gas-based systems. These have the advantage of not short-circuiting any electrical systems. They also leave no residue. However, they have been known to be bad for the environment because apparently they deplete the ozone layer. Now, the alternative is what we call the clean agent. It's an alternative to halon gas as they're not environmental damaging or toxic to humans. Let's round this up by talking about secure data destruction. At some point, eventually, data will need to be destroyed, but how it is destroyed is very, very important. So, physical security controls also need to take account of the disposal phase of the data life cycle. Now, media sanitization and remnant removal refer to erasing data from hard drives, flash drives, and tape media before they are disposed of. Now, there are several ways how we can destroy our hard drives. We can burn them, we can shred and pulp them, we can pulverize them with like a hammer, or we can simply use something known as degaussing, which is exposing the hard disk to a powerful electromagnet, which will disrupt the magnetic pattern that stores the data. However, we do have what we call the data sanitization tools. Now, the standard method of sanitizing any hard disk drive is called overwriting. And this can be performed using the driver's firmware tools or a utility program. Now, we have different ways of overwriting. The most basic is called the zero filling, which will just set each bit of data to simply 0. That's what it will do. And then we also have the single pass zero filling, which can leave patterns that can be read with specialist tools. We also have the secure erase SE and then the instant secure erase. These are other data sanitization tools. Now, for the secure erase, this was introduced back in 2001. The SATA and serial attached SCSI specifications do include the secure erase command. Now, this command can be invoked by using a drive array utility, or in Linux, you can use the HD PARM utility. On HDDs, this will perform a single pass of zero filling. And then the other one is the instant secure erase, the ISE. So HDDs and SSDs that are self-encrypting drives, SEDs, they support another option invoking a sanitized command set in SATA and SAS standards from 2012 to perform something known as a crypto ease. So drive vendors would implement this as the ISE, the instant secure erase. So with an instant secure erase, all data on the drive will be encrypted using the media encryption key, the MEK. So when the erase command is issued, this key will simply be erased, rendering the data unrecoverable. Thank you so much for watching. I will see you in the next class.